State Departments of Transportation, DOTs, and other agencies are working to preserve our roadways, keeping them safe and efficient for the motoring public. This can be a difficult task once pavement starts deteriorating, especially when it happens faster than planned. Delamination is often due to layer debonding or stripping, which engineers can't always see, especially in the early stages. Manual destructive testing methods for evaluating the pavement structure for problems can be time-consuming and expensive to state DOTs and reduce safety for workers and the traveling public. But state DOTs found ways to combat these issues through technologies out of the Second Strategic Highway Research Program, or SHRP2. SHRP2 solutions are a comprehensive and data-driven set of products, procedures, and best practices meant to help transportation agencies save time, money, and lives through innovative solutions to common transportation challenges. The program was a partnership between the Federal Highway Administration, the American Association of State Highway and Transportation Officials, and the Transportation Research Board. Advanced methods to identify pavement delamination, commonly known as R06D, features two new non-destructive testing technology systems that can detect problems in the asphalt pavement beneath the surface in a safer, faster, and less expensive way than previously done.
Right now, for state designers, the way to truly evaluate pavement is taking cores. And that's a very slow process, it's a destructive process, you're impacting the traveling public, which really is a problem. The nice thing about these technologies, hopefully, is it's going to provide the DOTs with information right away so they can identify those problem areas in advance, and then after that we can do some coring to validate what's actually out there.
One of the technologies featured as part of the R06D product is the 3D Ground Penetrating Radar, or 3D GPR. This technology uses an antenna array with a frequency sweep that can be operated at speeds over 60 miles per hour. The wide antenna array reduces the number of passes required to cover the lane width, saving time and increasing safety by getting workers out of the field faster. 3D GPR can identify moderate to severe distress as part of a systematic coverage plan of a highway project. The spectra analysis of surface waves, or SASW, and impact echo, or IE, are two more technologies that work together as a system to help identify the location of pavement delamination with automated test frequency every 6 inches in less than 1% of the time required by manual point testing. The technology travels down the roadway at walking speed and is best used to collect more complex data at spot locations. Users of the technology say they are able to detect delamination faster and with greater ease than ever before, not to mention less invasively.
There's some great advantages to the 3D radar in particular. We have been using a single channel radar which looks down and we get a reading for a 6-inch wide swath, and we find problems and we know how to process the data. The real advantage of this 3D radar is the full lane coverage. If we need to do that with our technologies, we have to do multiple runs. With this technology here, hopefully we can get the whole lane in one pass. And that'll save us time and all kinds of other and safety and increase safety. We're interested in the seismic technology because at the moment the stuff we do is static. We stand there, we bang on the pavement, and we move. With this new rolling technology, we think there's going to be definite speed advantages.
State DOTs testing the technology systems have had the opportunity to do so through the SHRP2 Implementation Assistance Program, or IAP, which offered financial support and technical assistance for each of the SHRP2 products. Xiangtao Dai of the Minnesota Department of Transportation found the R06D IAP helpful for his work.
This program is very helpful. First of all, the program provides us technical support and also financial support to each participating state. So I would say without this support, we probably cannot look at this technology and using this technology for detecting stripping right away in the Minnesota, because we have the funding constraint and also the resource constraint in our state.
While 3D GPR and SASW and IE are still being tested to fully understand their capabilities and limitations, their contributions to the transportation field are important in advancing non-destructive testing methods for transportation agencies.
These two non-destructive testing technologies have an analogy to the medical field, actually. If you think about in the old days of medical field, before they had x-rays, before they had MRIs, physicians had to go in and do exploratory surgery. Well, our pavement industry is a lot like that. We take cores and we cut trenches. These technologies allow us to do the x-rays and the MRIs to the pavements that we weren't able to do before.
For additional information on the technologies as featured in SHRP2's advanced methods to identify pavement delamination, or R06D, go to sharp2.transportation.org.